Hello, Whittier High School Algebra 1. This is Mr. Quattro. We're going to do notes today on 9.2 and 9.3, two pretty short sections. So the first one is 9.2, solving quadratic equations by graphing. Now remember, a quadratic equation is anything that has x squared. So these are our parabolas we learned before we went on quarantine. First thing you're going to do to solve a quadratic equation by graphing is to write it in standard form, which was the way we would look at them to graph them with the A, B, and C. And then once you've written it like this, we can graph it and find the x-intercepts. So let me show you an example. This will be actually the toughest example because you have to graph it. So here's our A, our B, and our C. Remember that we find the axis of symmetry, the middle of the parabola, with that formula. So we want the opposite of B. If B is already a 2, this is going to be negative 2 over 2 times the A, which is 1. So we've got negative 2 over 2 is negative 1. That means this is where the middle of the parabola is. So we've got our dotted line down the middle at negative 1. And then after this, we need to find the vertex. So we've got, this is the x value. The x is negative 1. We plug this back in as the x into the original equation. And you can use your calculator or you can do this by hand, but you would get I'm out of practice in writing. Keep breaking my pencil. I get negative 4. So negative 1, negative 4 is the vertex. And then we've got our, what in my class we called it the free point. The point they give you for free, you don't even have to do any work. You just know that negative 3 is the y-intercept. And then the free point on the other side. And since we're trying to see where this hits the x-axis, the x-intercept, we need to some more points here. So let's use a table to plug this in. If we plug in, say, 1 as our x value, so we can see where this is and if it goes 1 further over. If I plug in a 1 into here, this is where a calculator would come in handy. You get 0, which is this point right here. And then you have his mirror image or his reflection point over here. And we can see our nice parabola. Now what we're looking for when we're graphing these is we're looking for the x-intercepts, because where the graph hits the x-axis, these are the solutions. So this is a solution and this is a solution. So our solutions to this one, after we had to go and make the graph, are x equals negative 3 and x equals positive 1. Those are our solutions. Now you're going to see on our next examples, it's actually even easier than that. If they've given you the graph already, if you look, if they say solve the equation, we're just looking for the x-intercepts. I see 2 x-intercepts, one right there and one right there, and I just write them down. So my first one is negative 6, and my next one is 2. So solving from a graph is really easy. This one, I've got my graph, I've got my parabola. It only hits the x-axis one time. It like bounces off right there. And so we only have one solution, x equals 4. And on this one, you notice it goes, we've got our parabola and it never touches the x-axis. And so we would say that there is no solution. If it doesn't cross the x-axis, then there's no solution. All right, some quick vocabulary here. When they say the 0 of the function, that's when the function equals 0 or a place where it is an x-intercept. So really simply, you'll get the idea on this. We don't even need to write all these in. There are 2 solutions if there are 2 x-intercepts, or 2 places where the graph hits the x-axis. There is 1 solution if there is only 1 x-intercept, and there's no solutions, no real solutions, if there is no x-intercept. So watch, really, really easy. If you want to find the zeros, you're just looking for where the graph crosses the x-axis. So I can see this weird shaped graph crosses one, and then another time, and all three of those are the zeros of this function. So we have the zeros are when x is -3. I'm sorry, that's not -3. That's -1. And then right here, 2 and 3. So x equals 2 and x equals 3. There are three of them. On this one, if we're finding the zeros of this function, it's right here when x equals 0. And if we're finding the zeros of this function, a different function, it's right here when x equals -2. Here, if you count them, this W-shaped graph, we have 1, 2, 3, 4 x-intercepts, and so we list all of them, and all of those are our zeros of this function. So -2, -1, 1, and 2. Now at this point, you almost don't even need to write it down, but I want you to pause it and then do those two problems on the bottom there, write the answers down, find the zeros, the solutions. Pause it. All right, so what you should have gotten on this one is -3 and +1. And then on this one, you should have gotten only one answer of x equals 4. All right, one little variation on this. What if you can't quite exactly tell? It looks like, I don't really know, it goes kind of through the middle of nowhere. But if you look at the equation, if you remember our zero product property, if I want to know when this equals 0, something times something equals 0, then that happens either when this is 0 or when this is 0. And then we can solve these, and you're going to see that the answers on the graph match up with what we thought they would be. So this one over here that you can't quite tell what it is, well, it's actually just 11. And this one over here that you can't quite tell what it is, it's -6. So those are the solutions. We can see them on the graph, but we can see more precisely by doing the work. All right. This one is a little tougher. Actually, it's not tougher because we can see it straight off the graph. We could use the equation, but that would be a lot of work. So instead, if you notice, it crosses through right here at 0, and it crosses through at 3. So if you can see it easily on the graph, 0 is a solution, or a 0, and 3 is also. By the way, the book will sometimes use the word roots. Roots is the same as zeros. It's the same as x-intercepts. They're all the same thing. They're all same names for the same thing. All right, this one more example. I'm going to go quickly through it because you can see there's 3 of them, easy. All right, then on this last one, this one looks like a really hard question. We've got this weird fireplace arch, they say. They give you this complicated looking equation, and then they want to know what's the width of the arch at the floor level. So from here to here, how wide is the arch? Now, we need to figure out what this point is and what this point is. It's kind of like the one up above where we can't see exactly. So if we look at the equation though, we'll notice that this will equal 0 when one of these equals 0. And can you guess what the answers are going to be? Can you even imagine? The solution to this one is -18, which is that guy right there. And the solution to this one is 18, which is that guy right there. So they said this is measured in inches. If you want to know how far it is from this one to this one, it's 18 inches to get there and another 18 inches to get there. So the total width is 36 inches. All right, that is the first section, 9.2. The second section is using something that you did in the 9.1 notes, using square roots. So it's a pretty simple process with one little twist at the end. If we're going to solve things that have a squared like this, one way we can do it, if it just has a squared and no other x, just x squared, we can isolate the x, look at it again, isolate or get by itself the x squared on one side. So you'd have x squared equals a number. And then we undo the squared the same way we always undo things, by doing the opposite. So we take the square, oh my, forgot how to spell, square root. The square root is the opposite of a squared. And that's it. So let me show you some examples. So for this one, you think of these like two-step equations, like easy beginning of the year stuff. You want to get this by itself, so we do opposite. And then if I want to get this by itself, I need to get rid of the 3, so I divide the 3. And we get to here. Now the next step, like we said up here, is once you've isolated the x squared, square root of each side. So here's how this looks. The way I cancel the squared is I do a square root on this side, but then I have to be fair, and so I do a square root on this side. Now my squared and my square root will cancel. That's why we do this. And then we get x equals the square root of 9. Now remember, with a square root, whenever you do a square root, there is a positive and a negative value. There's positive or negative 3, because 3 times 3 is 9, but also negative 3 times negative 3 is 9. So there are two answers to this. Let's look at another one. I want to get the x squared by itself, so I get the x squared by itself. And then I get rid of the squared the same way as the last one. Square root, and I get the square root of 20. Now, you could leave it like this and just call it, because we don't really know the square root of 20. There's no two numbers to multiply to get to 20 to whole numbers. So, but you learned last time in 9.1 how to simplify these. And so this could actually be written as 2 times the square root of 5, because this is the square root of 4 times the square root of 5, and the square root of 4 is 2. But we always put a little plus or minus there because it could be positive or negative. This last one is an interesting one. Watch this one. So we're doing the same thing, seems like the same stuff, no big deal. And then we divide to get the x squared by itself, and we get to here. But now when we take our square root, we see, wait a second, you can't take the square root of a negative. Square roots of negatives are what we call imaginary numbers. You don't have to worry about that until Algebra 2 though. So in this one, whoops, if they try to find the square root of a negative, you say, nope, can't do it. There is no real solution. The only solutions are imaginary. All right, why don't you pause the video, take a few minutes and try these problems, and then I will show you the solution in a second. All right, I'm gonna go a little quickly through these so this video doesn't go too long. But it's the same steps as before. Let's see what happens. So this one looks like it might be that no solution one because you see a bunch of negatives, but look what happens. The negative divided by the negative is a positive, so that when I take my square root, we actually know the square root of 25. That's a nice one. That's just 5, plus or minus 5. On this guy, when you subtract the 12, and then when you do the square root to solve it, you have the square root of a negative, and we saw from up here, can't do that. So this one would be where we say no real solution. And the last one, something funny happens also. You get 43x squared equals 0. When we divide by 43, 0 divided by 43 is still 0. Now you got to think, when you do your square root, what is the square root of 0? Well, since 0 times 0 is 0, the square root of 0 is 0. And we don't need to write plus or minus on this one because positive and negative 0, it's the same thing. So it's just 0. All right, a couple variations on this. When they say solve it, same thing, using square roots, but we want to round our solutions to the nearest hundredth. So we're going to use our calculator to round it. So when I go about solving here, and then I divide the 4, when I do the square root here, I get the square root of 7, and I did not plan ahead because I'm using my phone, my calculator, for my video. The square root of 7 is, use your calculator, it's plus or minus 2 point, I don't know. You use your calculator and you get 2 point something and you round it off. Oh no. Same thing with this one. We get x squared equals 11. And then when we take our square root, we would use our calculator to type in the square root of 11. And we would get an answer, which again, I can't do. The square root of 11 is going to be plus or minus 3 point something. All right, pause the video for a second and try these two. All right, so when we want to solve this one, same thing, but we're going to get some decimals here, so this is going to be interesting. So we add 2, and then when we divide the 5, you get x squared equals, your calculator would tell you 0.4. And then when you take your square root here, you're going to have to use a calculator, and it will be plus or minus whatever the calculator tells you for that, which should be something like 0.6 something. You have to use the calculator. And again, I'm sorry, I'm using my phone as my calculator, or as my camera. And then the same thing with this one. You'd have to use your calculator to do this, and your calculator would tell you 11.3, and then when you do a square root here, your calculator should tell you the square root of 11.3 should be something like 3 point something, plus or minus. All right, the final variation of the problems here is this, and this is a little interesting, but you notice there's still a squared. You see how the squared is like blocking all of this in here. It's like locking that x minus 1 in there. Before you can do anything with that minus 1, you have to get rid of the squared. So we saw we get rid of a squared using a square root. And so we get x minus 1. You have to be fair and do the square root on the other side. And the square root of 25, we write our plus or minus 5. Now it's really simple. If I want to get the x by itself, I just add 1. Now this is a little strange though, you notice, because you have, look at all these plus or minus plus 1. It's kind of weird. Here's how we do this. This is a 1, a positive 1, plus or minus a 5. When we say plus or minus, we actually mean do it twice. 1 plus a 5, like do the plus, and then 1 minus a 5, do the minus. So we get one answer of 6 and one answer of negative 4. Let me show you one more time. The squared is locking all that stuff in there. It's blocking those parentheses. So we have to get rid of the squared first. And it cancels the squared. So we get x minus 3 is plus or minus 4. We add the 3. And we get a positive 3 plus or minus 4. So, two answers. 3 plus 4, 3 minus 4. That's a 7, that's a negative 1. All right, pause it one last time. Try these ones. Okay, so here's how we do this. Same thing, when you do your square root, you get square root of 9 is 3, and then when you add your 3, you get a positive 3 plus or minus 3. Do it both ways. 3 plus 3 or 3 minus 3. So we get an answer of 6 and an answer of 0. Last one. Whoop, can't do that yet. Can't subtract a 1 until we get rid of this squared. So we take our square root. X plus 1 equals plus or minus square root of 36 is 6. And then when we subtract our 1, this is the first time this has happened, you're going to get a negative 1 plus or minus 6. So be careful. When you do this both ways, it's negative 1 plus 6, negative 1 minus 6. And so we get a 5 and a negative 7. All right, the final problem. You've got a touch tank where you get to touch the stingrays or the fish or whatever they are. And they say the height is 3 feet. You can see it right there. The length is 3 times the width. So whatever, let's say that let's label this one here, the width, let's call that X. That would mean this is 3 times that, as in 3x. 3 times x. So if you want volume, the volume of a box like this is the length times the width times the height. So if we multiply all these things, the volume is length times width times height. And if you kind of combine all that together, you get 3 times 3 is 9, and then x times x is x squared. So our width here is our x, our length is 3x. But they tell us one more thing. They say that the volume is 270. So we could say the volume, which we found out was this, is 270, and this looks a whole lot like the ones we just did. So we can divide the 9. 270 divided by 9 is 30, and we can do our square root. So x equals plus or minus. Now here's an interesting thing. Since our x is our length, or our width, is there any way for the width to be a negative value? I don't think so. So in this case, since it's a real life measurement, we can throw out the negative and just say the square root of 30, which is not a nice whole number, and so we just call it the square root of 30. So that is the width, because we labeled it as our width, and our length is 3 times that. So this is our width, and our length will just be 3 times that, so we could say our length is 3 times the square root of 30. Now if you wanted, you could use a calculator to punch these in and see what these are as a decimal number. This would be 5 point something, and this would be 3 times that, so it'd be a lot bigger. All right. So now you have the practice that you have with this to practice these new skills that you've learned. I hope that you learned something today and you stay safe and don't drive yourself crazy in your house.